this is Britt Caswell with another example video. In this video, I'm covering example 2 from section 5.1 in the SavvasRealize Algebra 1 textbook. So the goal of this example is to transform the absolute value function, which I think is kind of a not exciting title for this section because it doesn't cover all the transformations. So the only transformations for the absolute value function that this graph covers is looking at the a value. Oops, that shouldn't be a curve there. Absolute values have straight lines. So the kind of general form for an absolute value function looks like this. Alright, so this section is only looking at the a value. And so this is going to be some kind of vertical change. Alright, and if a is a negative, you're going to have a reflection. If a is bigger than 1, so if it's like a 2, a 3, a 4, ignore the negative sign, but the actual number itself is bigger than 1, you're going to have a vertical stretch. And if a is less than 1, you're going to have a vertical compression. And so this section only talks about those changes. It doesn't talk about the h or the k value. So understand that the h value is going to be a horizontal change. And when you add or subtract h, if it says x minus h, it's going to translate to the right. And if it says x plus h, it'll translate to the left, which feels backwards, but that's just kind of how it does. And then the k deals with translations vertically. Because remember, if you do something outside the grouping symbol, it'll be a vertical change, and inside makes horizontal change. So if it says plus k, you go up, and if it says minus k, you go down. So these examples don't cover these transformations, these translations. But understand, your domain and range don't change for horizontal translations, and only your range changes for your k. So let's check out these a changes. So the original function, the parent function for an absolute value, looks like this. The slope of the right-hand side is 1, and the slope of the left-hand side is -1, and I'm going to try to draw it really carefully. So this is the parent function, f of x equals the absolute value of x. Okay? So when we take that parent function and we multiply it times 2, what we're going to have is a vertical stretch. Because what's happening is our y value is doubling, whereas our x value is staying the same. Alright, so we're doubling our output when we multiply the absolute value by 2. And so what you tend to get is you tend to get an absolute value that looks like this. So notice that it is now stretched. So this is g of x equals 2 absolute value of x. So we need to look at the domain and the range. So if you notice, the purple graph is still going to the left for forever and to the right for forever. So the domain does not change. Alright, it is still all real numbers. So now let's talk about the range. So remember, the range is describing the y values. So this one starts at 0, 0, just like the green one did, and it continues to go up for forever. So the range didn't change either. Alright, it is still y is greater than or equal to 0. So stretching the graph upwards or vertically did not do anything to the domain and range. In fact, nothing's going to ever change the domain. It'll always, with any of our transformations, it'll always have the same domain, just because the shape of the graph goes to the left and right for forever. We're always looking for some kind of change in the range. And in this case, stretching the graph doesn't change the range. So now let's check out part B. So again, our parent function very roughly looks like this. Alright, so that's f of x. So now h of x has a -1 in front of it. Alright, so if our a is negative, we're going to have a reflection. So we're going to take this graph and flip it right upside down, like this. So when we flipped it upside down, our domain doesn't change, right? Because it still goes from to the left for forever and to the right for forever. So the domain doesn't change. However, if we check out our range, now it still starts at 0, 0, but the red graph goes down for forever instead of up for forever. So the range is the opposite of f of x. Our range in this case is y is less than or equal to 0. So reflecting the graph upside down changed the direction of our range. So now let's check out this one. So g of x equals 1/2 the absolute value of x. So instead of the slope of this right-hand side being 1, the slope of the right-hand side is 1/2. I'm going to try very carefully to draw. Y'all know that the struggle's real for me though, so. Alrighty, so there is our graph. Now if you notice, this is a compression from the original graph, because the original graph goes like this with a slope of 1. So you could see that that 1/2 really flattened the graph out. Okay. Now again, the domain didn't change. It is still all real numbers. But the range, did that change at all? Not really, right? It still starts at the origin and then continues going up for forever. So the range did not change either. So whether we were stretching it, like in the first example, or compressing it, like in this example, the domain and range didn't change. It only changed when we reflected. Alright, so now here's our last one. So again, here's our parent function. Man, I should have just put a graph of the parent function on here so I didn't have to draw it over and over. But I'm getting better at practicing it, so there we are. So for this one, there's 2 transformations happening. Alright, the negative is a reflection, and the 2 is a stretch. So not only are we flipping this upside down, but then we're stretching it out. So if you notice, our graph is skinnier and upside down. So our domain, the graph still goes to the left and right for forever, so the domain didn't change. It's still all real numbers. But the range is just like in the last example, the range is the opposite of f of x. The range is y is less than or equal to 0 because it starts at 0, 0 and goes down for forever. So the only change to our range was when we did a reflection. You'll find later that when you do a vertical translation as well, that will also change your range. But there we go. There's some transformations on the absolute value function. Until next time.